Hi, and thank you for joining me in this video on meteorological instrumentation. We're in a section right now called Instrumentation Design and Selection. And here we're going to talk about instrument performance in this video. Instrument performance deals with how an instrument will respond as a result of some sort of input. And we can generally classify instrument performance as either being static performance or dynamic performance. Static performance has to do with how an output results from sort of input. In other words, what kind of change do you get with input? And we're not really concerned with how that changes over time. We'll get to time later on. So static performance does not deal with time, and it deals with when you change an input, the thing that you're trying to measure, how does your instrument respond? In other words, the output. We call one example of static performance sensitivity. In another video, we talked about sensitivity. Sensitivity is when you change some meteorological parameter. In this case, this figure shows a change in temperature. How does that result in the change in the sensor or the instrument? If you have a liquid and glass thermometer, how does the glass or the liquid expand within the glass? Dynamic performance, on the other hand, deals with time. So in other words, over a period of time, how does the instrument change? How does the sensor respond? And we have two examples of dynamic performance. One is response time, the other one is time constant. Response time is the time that an instrument takes to completely respond to a change in input. And usually we look at a step change. It gets a little bit more complicated if you look at sinusoidal changes or if you look at a ramp change. So we're looking at strictly at a step change, meaning that, for example, if we take the case of a thermometer in an ice bath where the temperature is 0 degrees Celsius, pull it out of that ice bath and put it in boiling water, which is 100 degrees Celsius. Over a period of time, how does that thermometer change over time? So with this step change, the thermometer or the instrument is going to respond differently. It's not going to respond precisely as the input. The input is a step change, as you see on the left-hand figure. The right-hand figure shows what the instrument is actually doing. And in this case, it looks like a curve. And specifically, it's an exponential curve. So the response time is the complete time that it takes to respond to that new value. In this case, we gave an example of an ice water bath where the temperature is 0. And then boiling water, sticking the thermometer instantly in boiling water. So over a period of time, how long does it take for that thermometer to truly record 100 degrees Celsius after coming out of that ice water bath? Another example of dynamic performance is time constant. And time constant is the time that it takes for an instrument to change or reach 63.2% of the response to a step input change. We talked about step input changes already. That's where the example that we gave, you have a thermometer in ice water and you plunge it into boiling water, that's a step change. So how long does it take for the thermometer to change 63.2% of that total change? So in other words, if you're looking at a change in temperature from 0 to 100 degrees Celsius from an ice bath to boiling water, 63.2% would be a change in temperature of 63.2 degrees Celsius. So when the thermometer reaches 63.2% Celsius, measure that time, and that is your time constant. So those were some examples of instrument performance. And in future videos, we'll look at other characteristics of meteorological instruments.